Okay, so the next thing is looking at another carboxylic acid reaction, which is esterification. So esterification means making an ester. An ester will always have a C double bond O, and an R group on either side. That's how I can identify if something is an ester. So, a carboxylic acid will react with an alcohol, and I've just drawn it in this kind of format, so it might go out of focus for a moment. And I've just drawn it in this format with the OH being this way around, just so it's easier when we look at atoms. Esterification is an example of a condensation reaction. Condensation reactions mean that we lose a small molecule. In this case, with making an ester, we lose a small molecule of water. If we need to make a molecule of water, that means I need to lose 2 sets of hydrogen atoms and 1 oxygen atom. Every single time you have an esterification reaction, you will lose the OH from the carboxylic acid, and you will lose the hydrogen from the alcohol. If I were to do this, and I lose that OH, and I lose that hydrogen, brilliant, I've lost my water molecule. However, I'm now ended up in a situation where this carbon has currently got 3 bonds, and this oxygen has currently got 1 bond. So what does need to happen is this needs another bond, and so does this. The carbon and the oxygen bond in the carbon and the oxygen, from the neighbouring molecules end up forming a bond between them. Of course, when we draw it out, we don't draw it out like that. We draw it a lot closer together. But for the purposes of now and just illustrating to you how that works, we lose the OH from the carboxylic acid and hydrogen from the alcohol, and then we form a bond between the 2 atoms. And that's called a condensation reaction, and it's esterification. This reaction is a reversible reaction, and it does require an acid catalyst, or a strong acid, such as concentrated sulfuric acid, in order for that backwards reaction to take place. So let's have a quick look at writing out what something might look like. So if I had ethanoic acid and I wanted to react it with ethanol. Ethanoic acid looks a little bit like this, and our ethanol looks a little bit like this. We can lose our OH from our ethanoic acid, and we can lose our hydrogen from our ethanol, and we could form our ester. So thinking about that as an equation, I had the CH3 COH, add CH3 CH2 OH. Remember, reversible reaction. My ester that I formed, so CH3 CO O CH2 CH3. Remember, I told you it was condensation, so you also produce a small molecule, in this case water. So that's just writing out our structural equation for this reaction. Let's try another one before we move on to naming. If I had methanoic acid, and I reacted it with, let's go for propan-1-ol. Thinking about our methanoic acid, that's our HCOOH. And I react with propan-1-ol. That's propan-2, apologies. Thinking about our end product, when we have this reaction, I lose that hydrogen, I lose that OH, and I form that bond between them. So I've got my HCOOH for the methanoic acid, my propan-1-ol is CH2OH at the start, CH2, CH3, and now I've formed this ester. So I've got an HCO O. Remember, this is the key part that indicates I have an ester. So I've got an HCOO, then I have a CH2, and I have a CH2, and then I have a CH3 plus a small molecule of water. Now when we name esters, they are named as alkyl carboxylates. So the first part of our name comes from the alcohol, and by default the second part of our name comes from the carboxylic acid. So if we now apply that to the first example that we have up here, let's apply it to our first example here. Well, the alcohol that I had was ethanol, so I'll form an ethyl. The carboxylate comes from our carboxylic acid. Carboxylic acid I had was ethanoic acid, so it's an ethanoate because we end with our carboxylate. Similar to what we did in the last one, we know it's a carboxylate, it ends with O8 plus water. Let's follow the same principle for the next one. When I need to name the ester, I have to look at the alkyl part first, so the part that comes from the alcohol. So the alcohol was propan-1-ol, so I have a propyl. Now I have to look at the part that comes from the carboxylic acid. Well, I had a methanoic acid, so I have a propyl methanoate. So that's that part, just with regards to naming and writing them out. A trick that it sometimes asks you is, instead of, this has worked because the OH is on carbon 1. This has worked because the OH is on carbon 1. Sometimes they might give you something where it's propan-2-ol, and I'd always suggest drawing it out first. Because imagine I had methanoic acid, but this time the OH is in the middle of the chain, and I've got my methanoic acid, and I have the propanol. I still lose the hydrogen, right, from the alcohol, and I still lose the OH here. So I still form that bond, but my structure now looks a little bit different. Let's draw this out a bit better. I've got my HC double bond O, directly bonded to an oxygen, but what this oxygen is now bonded to as well is a carbon, and that carbon has two sets of CH3 on either side. So I can draw one here, and I can draw one here. And it also had a hydrogen at the top of it. This now looks a lot more manageable in terms of naming and drawing out, but it's a little bit more challenging. So if I had to name this, well, I can say that the alcohol it's from was propan-2-ol, but really this doesn't look like a propan-2-ol anymore, because I don't have 3 in a straight chain. This carbon has to be carbon 1, and it has to be carbon 1 because it's the highest priority, because it's directly bonded to the ester linkage, and the ester, priority 1. So if this is carbon 1, it means one of these has to be carbon 2. So let's say I made this a carbon 2. That therefore becomes a methyl, and this is odd to what you might have done before, because normally we say we can't have methyls on carbon 1. Well, esters and something called N-substituted amides are the only time when that's not quite the case. So I can say I've got a methyl on the ethyl. The reason we're saying methyl and ethyl instead of O8 is because they're from the alcohol. And remember, the alcohol part goes first in every single one of these. So I have a methyl, ethyl, because the methyl is on the ethyl. Then the carboxylic acid that it was from is called methanoic acid. So I have a methanoate. If I'm to attempt or carry on, or give you a go at trying to do one yourself, if I had an ester that looked like this, Just pause it and see if you could try and name it. Remember, the alkyl part goes first, then the carboxylate. So try and identify this side is our alkyl, because it's the side directly bonded just to the oxygen. So this is my alkyl side. That carbon has to be carbon 1. So try and give it a go.